Good morning to my panel and my supervisor, Dr. Jeffrey Sabinti Momofuzi. Today I'm going to present my final year project, which is image steganography using AES and blowfish encryption method. This is an image steganography tool. My name is Kuganraj Manasundra and my trigger number is CI180038. For the introduction, this project is mainly about hiding information inside an image in a text format using encryption key. Steganography relies on secrecy by hiding information inside a secured medium. This technique used in this tool is least significant bit and discrete cosine transform technique. The embedded information is secured by cryptographic algorithms such as AES and Blowfish. The only way to retrieve back the message from the image is by decrypting the image with the embedded secret code. For the problem statement, the main problem statement in this image steganography is a suspicion. A visible encrypted text will draw the suspicion from others. This will make an attempt to decrypt the ciphertext. So there will be a huge chance of message being viewed by third party in the exception of sender and viewer. The quality of the technified image will be different from the original image, which may lead suspicious to the third party. Second problem is regarding the risk. There are a lot of ways to share the message with others using a lot of media platforms such as Facebook, Messenger, WhatsApp, Instagram, WeChat, and many other platforms. All these platforms have some common thing which is called as a risk. So, whenever a person sharing their information through the online platform, there is a possibility of an intruder who eavesdropping our conversation. So this tool will try to solve and give an answer for that problem statement. The objectives are to design an image steganography tool using hiding text inside an image, to develop an image steganography tool by applying encryption method, and to test the image quality by using PSNR evaluation parameter and error rate for discrete cosine transformation technique. The scope of study is we have 6 scope, which is key, encode, decode, confidentiality, integrity, and availability. Key, we act as a private and public key to hide and unhide the secret message. Encode, the text will be hide through the encryption method, which is AES and Bluefish. Decode, the text will be shown through the decryption method such as AES and Bluefish. For the confidentiality, the image only can be viewed by the user who holds the original key. For the integrity, only the legitimate user can alter or modify the text inside the image. Availability, this tool does not require internet connection and fully available in offline mode. So for the comparison in my literature review, first I would like to compare my system with image steganography using LSB system. This tool is to hide the content inside an image, and encryption of data file in the image will make the document more secure. The LSB embedding is the most common technique to embed the system bit density coefficient. This method also been used in spatial domain where least significant bit value of a pixel is changed to insert a 0 or 1. Next is a text file hiding in an image. This is a typesetting tool which is very useful for producing technical or scientific document with professional page layout. This technique is now similar to other type word processing software such as Word. TEX does not have instant formatting result on the screen, but it is using to control sequence command to manipulate the scheme of and page layout. Next is high capacity image steganography using modified LSP substitution and PVD against pixel difference histogram analysis. For this particular tool, the image partitioned into different blocks with size of 1 times 2 pixels. For block difference value between 2 pixels is computed and changed to a new value by hiding data in it. The PVD technique with block size of 2 times 2 has been proposed to enhance the embedded capacity. For the Quick Stego is a software that leads the user to hide the text inside the picture so that the only user of Quick Stego can explore and read the hidden secret message. Once the text we choose is hidden in an image, the saved picture is still a picture. It will load just like any other image and appear as it did before. The image can save, email, upload to the website as before. The only difference will be it contains hidden text. Next is Steganography. This Steganography using encryption algorithms such as RC4, DDS, and hashing algorithms such as SHA and MD5. This tool is a hybrid steganography tool that allows user to hide files within BMP and WAV file. This will also allow user to encrypt the hidden file with a variety of supported encryption algorithm, including RC4 and DDS, and hashing algorithm, which is SHA and MD5. So my tool, the proposed tool is image steganography using advanced encryption standard method and blowfish method. In this particular tool, we have used AES encryption, blowfish encryption, DCT technique, and LSB technique. The proposed tool is to embed a secret message inside an image using AES encryption. The tool allows the user to encrypt the hidden file within a variety of supported encryption algorithms such as AES and blowfish. The technique used in this tool is LSB and DCT. So the methodology we use for this tool is object-oriented analysis and design. For the requirement, we have gathered all the information regarding the steganography and the existing steganography tools. Then we've analyzed the problems and the upgradation needed in the image steganography research and existing tool. Then for the object-oriented design, we have designed a pre-designed tool interface and get approval from my supervisor Dr. Jeffrey Sar, and we have designed a new interface for the tool. For the object-oriented implementation, we have done this project using Visual Studio Code and Python programming language. All the implementation and algorithm was done through the backend and frontend. For the object-oriented testing, we have tested with user testing and functionality testing. For the user testing, we have tested with different IT professionals from Hitachi Information Data System professionals, Genting Sendriam Rehat IT security professionals, and students from different universities such as UNIMAP and University Pahang. Overall of the flow of the tool is, first the application will be started by the user. The user will choose the encode button and will select the image and encode using the LSB or DCT method. The user will choose the encryption method within AES and blowfish. So a new image will be created with the hidden text. For the decodation part, the user will choose the image, enter the key. The secret message will be shown once the secret key correctly initiated. The overall flow will be explained in further. First, choose file, text, and image. Once the selection is done, the user now can embed the text by clicking the embed button. Once the embed button successfully embedded, new image will be appear and can be downloaded by the user. Later, the user can check the difference of the quality between two images. Second, encode text inside the image. This is the first step of formation of steganographic message. The user needs to select an image from his or computer. Once the image is loaded, the user needs to select the encryption method to be used. Then the user needs to type a message for hiding it. Third, for the decodation part, once the encryption is done successfully, the user can decrypt the image by reversing the same steps above. The original text will be shown once the secret is initiated correctly. This is the system diagram of the image steganography tool. This part is already explained earlier in the overall flow of the system. Uh, for the UML part, Unified Modeling Language part, first I would like to explain the user case diagram for the user. First, the user will input the plain text, then select the image, then select the encryption method, which is AES or Blowfish. Then the user will select the technique LSB or DCT. Then the user will give a secret key and enter the message to be embedded. For the decodation part, same. The user will select the image, input the key, view the message, select a new image and reply with the same process. For the execution part, the sender will select a message and image, takes the message and the image, encrypts the image within the message within the image, and creates a new image in the same directory and sends the image file to the receiver. Receiver receives the file, display the decrypted message using the secret key, and reply with the same process. For the activity diagram, the sender will initiate the steganography encryption, select the secret file, then the user will select the cover image, then the sender will encrypt the file using the encode button. Then the file will be sent. For the steganographic decryption, the receiver will load the image file, save the file, and decrypt using the correct secret key. What we expected result. In the end of this project, the user can hide the text inside a PNG and BMP image in a secure way, and the message is secured by the AES and Blowfish encryption method. The technique used is LSB and DCT. The user can retrieve the message from the specific image by using the correct secret key. All the encryption method and technique works fine and able to hide the secret message within the image. The importance and the contribution. Secondary technology are a very important part of the future of internet security and privacy on open systems such as internet. Steganography research is primarily driven by the lack of strength in the cryptographic system on their own and the desire to have complete secrecy in an open system environment. The steganography can be used to hide the important data inside another file so that only the legitimate user can get the message even knows the secret message exists. The proposed project able to reduce the security and privacy issue among the organization and the people. The secret message may not be able to break by the intruder. The encryption method will be help the user to hide the message by encrypting an unreadable context. Fourth, lastly, the secure environment and secure feeling may feel by the user. This is the Gantt chart I have done. The Gantt chart will be start from the project initialization, gathering information analysis, methodology, system design, system implementation, testing and maintenance, and report preparation. All these phases was monitored by the supervisor. This is the pre-design I have done, and this is the main interface. This is my final output. This will be my main interface. This will be the user manual. There will be 3 user manual for the user to know what is image steganography, how to use this tool, and how to use the DCT option inside this tool. This is the encode page. For encode page, the user will choose the image, and there will be encoding method, encryption type, output image type, message bar, secret key bar, and output file name bar. Then once the user done all the needed requirement and give the encode button, there will be a pop-up message successfully created a new image. The image will be created in the same directory. So the new image was created with the text file. The text file will contain the timeline, secret key, encrypted text, and the file name. The quality comparison. The quality of the LSB won't be much difference. There will be a slight difference only. For the decoding part, the user select the encoded image and choose the encoding type, encryption type, and a secret key to view the secret key. The PSNR result and error rate of DACT is shown here. This is the user testing form I have given to the testers. The response are collected and these are the sample responses. The testers are Purani, Anishwaran, Sumitra Devi, Kishan Raj, Harshini and Ramesh. They are from different area of job titles like software developer, student, automation engineer, technical consultant, trainee and IT executive. Okay, the demo section will be shown in a while. For now only this from me. Thank you.